Hello everyone, welcome to our CS225 final project presentation. We are a group of four. We have Yunfan, Yixiang, Jinrui, and Jiayu. Our project goal is to get the shortest path between two airports, and we successfully achieve our goal by implementing the Dexter's algorithm and the landmark algorithm. And we have this SPFS traversal. Um, so we basically spent the first 2 weeks of April to finalize our goal and search for useful information about how we're gonna finish out this project, right? So we decided to build a graph. So here, the airports are the vertices of the graph, and the available flight routes are the edges, right? So to build this graph, we have many choices, right? We have the adjacency matrix, we have the edge list, we have the adjacency list. But we choose the adjacency list because it is easy to insert edges and to tell whether the two vertices are adjacent or not. And also it has a distant running time of inserting vertices and get the incident edges, right? So to really begin finishing our project, we first downloaded the data set from the website. It's this one, openflies.org. um and found out that we need to parse the string, right? By we read the text it gives, right? And then based on the information we got from the file, we built up the airport class and the coordinate class. So let me show you those classes, right? So this is the airport. So we have the airport ID, the name, the country, the city, the IATA code, the coordinate, and the coordinate header, right? So we have the latitude, we have the longitude, right? We set the latitude and longitude as the factors of calculating the weight of edges, right? And we got this function to really calculate the distances. Um, okay. So when we really build a graph, so here's the graph. Um, we instead of using airport map, airport route to store objects directly, we use int map int long double to store airport ID and route distance, and we use a map to link those stuff to airport objects because it's more efficient and improves the performance a lot. Um, we also we implement the Dexter's algorithm by using map instead of the priority queue, as we think this should be more appropriate to our project, uh, as what we have what we have done before, right? So um here is the Dexter's algorithm, and here we also have the landmark algorithm, right? So this is pretty useful when you have, say, um, basically you have a destination, you have a departure, but there's a midpoint airport that it goes in. I mean, that's in the shortest path between the departure and the destination. Okay. Uh, so here is the FPS traversal, right? We traverse all the airports or not, right? Or don't traverse anything, right? We, yeah. Okay. So that's basically some important codes we have. So now I think you're familiar with our codes. Let me show you how our program work. Okay. So here, so this is the terminal, right? I will type make. Our final. Okay, so it may take like 30 seconds to build the graph, right? So just wait. Well, it may takes a few seconds. So yeah. Okay. So now it works. So let's say if I have say LAX to be the departure and say or D as the destination, right? Remember that we have to type the capitalized letters here. If we said the LAX not capitalized, then this is not gonna work right here. So yeah, it's showing up. So the LAX, we have the name, country, city, the distance here, right? And here, yeah. Okay, so let me show you what happened if I uh, type not the capitalized LAX. LAX or D. Oh, wrong airport code. Okay, what do we have? If we have the same destination and departure, so here, so LAX, LAX. Oh, that's invalid input. Another, interesting circumstances is that, say if I have, say AAA, yeah, this airport really exists, and PVG, okay. Oh, it says one of them is a ghost airport, right? So a ghost airport is that, this airport does exist, but there's no information about its routes, so it becomes a ghost, right? Um, so yeah, that's basically that's the results of our project. Yeah. Okay. Um, there's also something like we learned from. Oh yeah. One more thing. Yeah, let me show you. So this is P, and so let's say if I want to go from PVG to HGH. So basically, PVG is Shanghai, China, and HGH is Hangzhou, China. They're pretty close, right? Probably, like 200 miles, probably, I guess. Yeah. But you see here, we first go from Shanghai to Fuzhou, and then from Fuzhou to Hangzhou, which is, unnecessary, right? When you have such a, like short distance, you don't really have to. There's no need to take the flights, right? It takes you more time. Like in reality, people would just take trains or cars to travel, right? So that's something we learned from this project, right? For most of the time, the algorithm can give us what we really need, but there are some situations that the algorithm doesn't really help, right? So yeah. And also this project solidifies the knowledge we learned from this class, such as the mapping, the dexterous algorithm, the landmark algorithm, and some traversals, right? Yeah, we really enjoyed it. So yeah, that's all for our project. Hope you like it. You have a great day.